Welcome to the deep dive. So our mission today is exploring a really fascinating energy situation in Kaneohe, Hawaii. It's this place known for, tons of sunshine, but also notoriously heavy rain. And you might think, okay, sun and rain, solar power, maybe not the best mix. But we're going to dig into how Kaneohe is actually, well, rewriting the rules. They're turning this climate challenge into kind of an unexpected advantage, showing how resilient solar can be, even, when it's really wet.
It's quite the puzzle, isn't it? I mean, Kaneohe gets loads of sun, high solar insolation, technically speaking. We're talking maybe 5.5 peak sun hours daily for fixed panels. Think of that as the equivalent hours of full direct sun. But then, yeah, it also gets around 30 inches of rain a year, mostly concentrated, like November through March. So the big question is, how do they keep the lights on? How do they maintain energy production with that kind of fluctuation?
Okay, right. So the first thought is just rain equals bad for solar panels.
Beautiful.
And yeah, in some ways it is. Heavy downpours, they can definitely cut output, maybe 30, even 50%. And you see these seasonal dips, like winter output can drop by half sometimes. We've seen that with Tesla solar installations there. But here's where it gets really interesting.
Yeah, what's actually fascinating is that rain isn't just a problem. It's actually a really critical natural cleaning mechanism. Think about it. All the dust, and especially in Hawaii, all that salt from the ocean air that builds up on the panels, rain just washes it right off. And that can improve efficiency quite a bit, maybe 10 to 30% after a good storm. Some studies show that panels cleaned by rain, they can operate at like 95% efficiency compared to dirty ones. And the panels themselves, structurally, they're built tough. They have to be, right, for tropical storms. Things like encapsulated PV cells, strong mounting systems. You see that in big projects like Long Road Energy's Mahi Solar.
Huh. Okay, so that's a real upside. Rain dampens output short term, but the cleaning makes them more efficient long term. Interesting trade-off. But, okay, beyond just cleaning, what about new tech? Are we seeing innovations that actually, I don't know, use the rain?
Absolutely, yeah. That's where things get really cool with technologies like triboelectric nanogenerators. 10Gs for short. These are tiny, tiny devices. You can layer them right on top of the solar PD modules, the part that actually makes electricity from light. And get this, they actually harvest the kinetic energy from raindrops hitting the surface.
Wait, so the raindrops themselves hitting the panel generate electricity? That sounds almost sci-fi.
It sounds like it, but it's very real. There are these advanced ones, perovskite quantum dot tangs. They achieve something like 24, almost 25% energy conversion from the raindrop impact. And they do that while letting nearly all the sunlight, like 99%, pass through to the solar cells underneath. It's pretty amazing. There are even self-cleaning versions using cellulose-based tens. And this isn't just lab stuff. People are working on integrating these into actual projects.
Okay, incredibly advanced stuff. But is this really happening now? Are these kinds of solutions actually being deployed, or is it still mostly theory? Can you give us some concrete examples?
Oh, yeah, definitely. Look at the Mahi Solar and Storage Project. That's Long Road Energy again. It's huge. 120 megawatts of solar plus 480 megawatt hours of battery storage. It's set to power something like 40,000 homes. And check this out, it even supports agrivoltaics.
Agrivoltaics?
Yeah, farming under the solar panels. It's this amazing integration of tech and, well, nature. Then there's another one, SunSpear Energy's solar carport at Wet n Wild, Hawaii. It's smaller, 1.3 megawatts, but it uses Tesla Megapack batteries. So when it rains, they can dispatch that stored power, cuts their grid reliance by like 70%.
Right, so it's not just about making power when it's sunny, but smartly managing it when it's not.
Yeah.
So what does this mean for your wallet? If you're a homeowner in Kaneohe, does this pencil out?
That's a key question, right? What about the economics for you, the resident? Well, residential solar there, you're typically looking at a 5 to 10-year ROI, return on investment. And that's helped a lot by Hawaii's incentives. There's the 30% federal tax credit, plus state programs. Take like a 9.6 kilowatt Tesla system with their Powerwall batteries. It could drop your monthly electric bill from maybe $300 down to just $30.
Wow.
Yeah. And battery programs are key here too. Like HEOCO, the utility, has this battery bonus program. It actually pays you for sending your stored battery power back to the grid when they need it most. And we're also seeing some really powerful community efforts like the Oahu Energy Cooperative on Molokai. They're focusing on getting solar access to low-income households with projects like Palau Solar and Kuala Solar.
It really does feel like a blueprint, not just Hawaii, but maybe for lots of tropical regions facing similar, sun and rain challenges.
Looking forward, yeah. If we can scale up integrating these enhanced 10X, They might offset, say, 15 to 20% of energy losses on rainy days. That's significant. And think about AI-driven maintenance predicting the best times to clean panels or even optimizing their angles.
So, wrapping this up, what does this all mean for you listening? It really shows that even in places you'd think are tricky for solar, like really rainy areas, innovation is finding ways to make renewable energy more reliable, more consistent, and more accessible.
Exactly. And maybe a final thought for you to chew on. As our global climate patterns keep shifting, more unpredictable weather, how essential might these kinds of hybrid energy solutions, the ones pioneered in places like Kaneohe, become? For cities and energy grids, maybe in places you wouldn't even expect today. Food for thought.